And in order to do this, I'm going to draw a section of the mesh. I'm going to sketch a section of the mesh. And let's suppose that we're talking of a node there. Now that node lies in general, if that is just an interior node, it lies at the intersection of a number of elements. It's important to draw this one carefully, so I'll try to be a little more careful. Okay, that is where things start, and to complete this picture I'm actually going to go to other colors. So I hope that will make things clearer. Okay, this I'm going to extend out to there. Okay, we have that, and I'm going to also do the following. I have that. I realized that I drew a line which actually should have been dotted. Okay, I'm going to redraw that line and make it dotted or dashed. Okay, then this line also is dashed. It is joined by this one. Okay. This one comes out, it comes down all the way here, joins up there. Which says that this thing and that should also be dotted. Okay, this one is complete, this one is complete, and right, I need to have this, that. Okay, and back here I have another one here. Okay, and this goes all the way down here. Remarkably enough, I think I've completed it. Okay, what I'm trying to show you here after a few minutes of hard work is the fact that I have here, if we look at it carefully, a node, right? I have here a node which I'm going to denote as a bar, because it's a global node. Okay, so what I have here is a global node global degree of freedom A bar. Okay, and that's the node corresponding to the global degree of freedom. All right. I want to emphasize here that it belongs to how many elements? I know that may look like a messy sort of figure, but I think the basic idea is conveyed. It belongs to 8 different elements, right? And let's label the elements to which it belongs as the different color again. Let's label the elements to which it belongs as the element that is sort of in front, bottom, and to the left is E1. The one next to it is E2. The one behind it is E3. And the one all the way in the back is E4. I'm not going to try to label it. Okay? We continue. I'll call this element which is to the front, up, and to the left as E5. The one that's front, up, and to the right as E6. The one that is behind, to the right, and up is E7. The last one is E8. Okay? So what I'm trying to show here is that a general internal node belongs to 8 different elements. Okay? Since we are working with hexahedra. So global degree of freedom A bar in general belongs to 8 elements. Okay, here marked E1 up to E8. Okay, all right. So now what one can observe is that if we follow a numbering system in which for a single element we have a numbering system of the following type. Right, the local degrees of freedom of this element. Right, we've been talking of numbering as 1, 2, 3, 4 down there, 5, 6, 7, and 8. Okay, this is A equals 1. Okay, so this is local degrees of freedom numbering. Okay, now the big question here is, and this is an important one, how does one represent the way our global degree of freedom A bar shows up as a local degree of freedom in each of the 8 elements to which it belongs. Okay, this the answer to this question is what we call, well, or what generally describes this sort of information is what we call mesh connectivity. Okay, the way this is typically provided in the context of a finite element problem, right, is to provide it during input, right? This is provided typically in an input file. Right, it may be in an input file, or in some cases, if the meshes are fairly regular, this sort of thing can be just generated on the fly. Okay, typically provided otherwise in an input file. Okay, and the way that that file is specified is the following. Right, what you will have is a listing of elements. Right, so you may have here element the listing of nodes for element E1, or the degrees of freedom for element E1. You may go on, do other things, and then you may come to element E2. You may have E3, E4, E5. Maybe they're not all sequential. You have E6, E7. Sorry. E7. I think I'm running out of room here, so let me just give myself more room. E1, E2, that is how I indicate that they need not be sequential in numbering, right? E3, E4. So the elements don't have to be sequential. E5, E6, E7, E8. Okay, so the elements surrounding node A, right, the elements to which node A bar belongs, do not have to be sequentially numbered in the global, in our global mesh. Okay, all right. Now, but then let's look at things now. What we do for element E1 is simply list the global degrees of freedom that correspond to element E1's local degrees of freedom 1 through 8. Okay, so let's see how things work out for this. In this particular case, and I realize I did indeed miss a couple of edges, so let me just provide that in the figure. I did miss this edge. And now I think things are complete. All right. Now, with this setting, let's look at element E1 as listed, as drawn here, and ask ourselves the question, what is the position of global degree of freedom A bar relative to element E1? Following the numbering, the local degree of freedom numbering that I have here, it appears to me that A bar is local degree of freedom 7. Okay? As I speak, I see one more place where I've missed out an edge. Let me get that in here. It's this edge. Okay. All right. So for element E1, A bar is local degree of freedom number 7. So what one would have here is that you would have other global degrees of freedom in the positions 1, 2, 3, 4, 5, 6. In position 7, you would have A bar. In position 8, you would have something else. Okay, so we go on with that. For element E2, the way I've drawn things out here, A bar would be degree of freedom 8. Okay, so for element E2, all these positions would have other global degrees of freedom. Its position 8 would have A bar, right? The number A bar, right? Okay, where A bar would be the global degree of freedom number for that particular node. Okay, things would go on. I'll just complete it for this case. For E3, it is 5. Okay, for E3, it's 5. So 1, 2, 3, 4. A bar, which is 5, 6, 7, 8. For element E4, which is the one on the bottom layer behind and to the left, right, the one I didn't mark, A bar is degree of freedom 6. Okay, so for E4 is 1, 2, 3, 4, 5, A bar 7, 8. Carrying on now, for E5, it is degree of freedom 3. So 1, 2, A bar 4, 5, 6, 7, 8. For element E6, it is, right, for element E6, it is number 4. So it's 1, 2, 3, A bar, 5, 6, 7, 8. For element E7, it is actually degree of freedom 1. So we have A bar, 2, 3, 4, 5, 6, 7, 8. And finally, for element E8, that is local degree of freedom 2. So we would have something else in position 1, A bar in position 2, 3, 4, 5, 6, 7, 8. Okay? So this information is the critical bit that carries all we need to know about mesh connectivity. All right, and now as you have more and more elements in the mesh, you would have a similar array, if you like, for each element. Some authors and some books, I guess, refer to this as a local destination array. Okay, but that's just a very specific name for it. Anyhow, the important thing is that we need to provide this sort of information. And then where would we use this information? Well, we would use this information now in recognizing that for, as we set about assembling our matrices and vectors that come from our element level integrations, when we assemble them into global matrices and vectors, those global matrices and vectors are going to have components that are numbered by a bar, right? So any place where an element has a local degree of freedom corresponding to the a bar degree of global degree of freedom, the corresponding component in the stiffness matrix, for instance, would be added, or the corresponding component in the force vector would be added on. Okay, so we'll stop this segment here. When we come back, we will take this particular case and try to construct the contributions to the stiffness matrix and force vectors. Okay.